Hi everybody, in this video we're going to be going over the linked list cycle question on Neetcode's 175. So in this question we're going to be using obviously the linked lists, data structure, and we're going to use an algorithm called rabbit and tortoise. But you also might have heard it called fast and slow. So just look out for those two things as we go through the video. So I'll describe the question a little bit. So we are given as input a linked list, for example like this, and our job is to determine if this linked list is a cycle. So a cycle is a linked list that never ends, or in other words, that never points to null. So for example, this right here is not a cycle because it does not point, or it does point to a null variable, right? However, this right here would be a cycle because it never points to null, right? So this last element always points to 2, and we go through this cycle indefinitely. So our job is to output true if it is a cycle like this, and output false if it's not. So what we are going to do is we are going to use a rabbit and tortoise algorithm. So let's explain how that works. So you might notice that, or you might be confused, how are we going to actually detect it, right? Because obviously if we have something like this, how can we tell that it's going to point back? So yeah, we'll use the rabbit and horse algorithm. So let's explain that really quickly. So in the rabbit and the horse, or the rabbit and the tortoise algorithm, I don't know why I said that, but the rabbit and the tortoise algorithm, we have one pointer that moves slowly and one pointer that moves fast. So for example, let's have a linked list like this. Notice, let's say that we have our rabbit red here and our tortoise red here. After one iteration, our rabbit would move 2 steps ahead, so he would be here, and our tortoise would move 1 step ahead, so he would be here. On the next iteration, let's just extend this really quickly. Our tortoise would move 1 step ahead again, and our rabbit would move 2 steps ahead. So notice that the rabbit is always 2 nodes ahead of the tortoise. So that's how it works. Now let's see how that's important to this problem. So let's look at an example where it is in fact a cycle. So this right here is a cycle. Let's start at head and use the rabbit and the tortoise algorithm to see how it progresses. So we start here. I'll make these arrows. After 1, the tortoise will be here, and the rabbit will be here. So erase that. Next, we move the tortoise here, and the rabbit goes here. Next, the rabbit goes here, or the tortoise goes there, and the rabbit goes here. So notice that in this example where it is a linked list, the tortoise and the rabbit eventually point to the exact same location. And this is the most important idea from this video and the rabbit and the tortoise algorithm. If we have a linked list cycle, eventually the rabbit and the tortoise will point to the same exact location. So that is our goal when we are writing out this code. We're going to check, we're going to start at head like we did before. So we'll have both pointers at head. We'll move them along. The tortoise will be here, and so on. And we will check if they go to the same exact spot. An example where it is not a linked cycle is actually pretty self-explanatory. So obviously we're going to notice the rabbit and the hare start here. They move 1 and then 2, and then he moves 1 and then 2. So you'll notice that the rabbit will eventually point to an actual no pointer. So then we'll know that the linked list is not a cycle, right? So now that we know, or now that we've seen this solution, let's go up and code it. Okay everybody, so let's go ahead and code that solution. So like we mentioned in the video, the first thing we're going to do is we are going to just clean this up. We are going to set 2 pointers to the head to start. And for simplicity or for comprehension, we'll call one rabbit and we'll call one tortoise. So right now we have 2 pointers point at the head of the linked list. Then we're going to iterate the list. So we're going to do this while rabbit is not equal to no pointer and rabbit next is not equal to no pointer. So to explain that, we don't want the rabbit to, or if the rabbit is ever at a null pointer, or if its next ever points to a null pointer, we immediately know to stop this loop and we'll return false. This is not a cycle because it does reach a null pointer at some point. So remember, the thing we check is if rabbit equals, or the first thing we'll do actually is we will move the rabbit 2 ahead and the tortoise 1 ahead. So the rabbit is going to equal rabbit next, and the tortoise is going to equal tortoise next, right? So once these are moved 2 ahead and 1 ahead respectively, we are going to check if rabbit is equal to tortoise, and in that case we will return true. If they ever point to the same location, then we know that it is a linked list cycle. And that's it actually. It's a pretty quick solution. And the one question you might have had, because I even tripped up on it a little bit, was that why did I start with this? Well, if you'll notice, we both started them pointing to head, right? So if I did this if conditional statement first, as if I did this, then obviously we would immediately return true because they're both pointing to the head. So that's not how this algorithm works. So we obviously need to make sure that we move them both 2 steps ahead and 1 step ahead before we start the problem. And yeah, that's it. And if this entire while loop fails, as in it reaches a null pointer at some point, then we return false. So that is our solution. Let's just check I don't have any compilation errors. And yeah. Nice. Alright. Thanks for listening.